Welcome back. The topic for this video is phase diagrams. So just as a quick refresher, remember your phases are solid, liquid, and gas. And as you transition between a solid to a liquid, you're going to have that melting and freezing point. Between liquid and gas, you'll have condensation and vaporization. And if we go straight from a solid to a gas, that is sublimation. Or if we go straight from a gas to a solid, that's going to be deposition. Okay. Now we have a fourth phase that's pretty rare when you have extreme cases of temperature and pressure. Okay, and the temperature we call the critical temperature, and the pressure is the critical pressure. We have what's called a supercritical fluid. So if you have a supercritical fluid, what's happening is that the liquid and vapor the meniscus between them are disappearing. And so you get this kind of combination that's both a gas and a liquid phase, right? So in this picture on the left, you can see that there is a clear line between the liquid and the gas phase. But at critical temperature and critical pressure, we no longer see that distinguishing feature between the liquid and the vapor, and so we get what's called a supercritical fluid. So basically, when you reach this critical temperature, the gas cannot be condensed back into a normal liquid, no matter how high that pressure gets at that point. So, phase diagrams, these are going to be graphs where we're going to see the different states and state changes at various temperature and pressure conditions. Okay, so the regions are going to represent your states, your gas, liquid and solid, and supercritical fluid. And then the lines are going to represent your state changes. So that's the melting, freezing, sublimation, deposition, and at that line, you're going to have both states coexisting, right? Your triple point is a special point where at a certain temperature and pressure, you have all three states, your solid, liquid, and gas, coexisting at the same time. And for most substances, the freezing point is going to increase as the pressure increases. So let's look at a typical phase diagram, right? Again, that triple point you can see is where we have all three phases, the solid, liquid, and gas. When you are at normal pressure, and typically the normal pressure of graphs is going to be very far down to the bottom corner, at normal pressure and very low temperature, typically you're going to have your solid phase. And then as you go across, you may go through the liquid phase or you may go straight to the gas phase. And just estimating here, the normal temperature is probably somewhere in this region. So you can tell that at normal temperature and pressure conditions, this is probably going to be a gas. And then you can see how we can transition if we're at higher pressures, go from a solid to a liquid to the gas phase. And then, of course, if you are at extreme temperature and pressure conditions up here, you can see how that line disappears at the critical point. And beyond that point, we're going to have this supercritical fluid phase. Okay, where there's no longer a distinguishing feature between the liquid and the gas. So here on the left is the typical phase diagram that we were just looking at. Now on the right we have the phase diagram for water. So one thing I wanted to mention is unique about water. We talked about how as the pressure goes up, right, and let's go back and look at that. The freezing point increases as the pressure increases. So if we look at the pressure going up and just starting from that triple point there and going up through, we can see that the freezing point temperature, and remember freezing is right here, this line, is increasing, right? So as the pressure increases, the temperature increases. And so you should see that that's a positive slope, right, as we go across the horizontal line. So again, as pressure increases, the freezing point temperature is increasing. But for water, notice how if we, again, take that triple point and trace a vertical line up, we can see that it's inversely related, right? As the pressure goes up, the freezing point temperature actually goes down. So that's just a unique feature that water has. So let's try to answer a few questions about phase diagrams. What phase transition occurs at about -75 degrees Celsius and 100 kilopascal? So remember, 100 kilopascal is going to be pretty close to the normal pressure, right? Remember, normal pressure or normal vapor pressure is 1 atmosphere. So right here at 100 kilopascals and -75 degrees Celsius. So we'll say -75 is here between 150 and 100 kilopascals. We're looking at this point here, and they're asking what phase transition that is. So remember, at very low temperatures, we should have a solid. So this blue line here should represent our solid. And then at very high temperatures, we should have a gas phase. So if we look way out here at the high temperatures, this is going to be our gas phase. And so that leaves the purple region as our liquid, and then the green as our supercritical fluid region. Okay, so what's happening is that we're going between a solid and a gas. And so depending on the direction that we're going, it would either be sublimation or deposition. And I assume if they're trying to go from a solid to a gas, it's probably going to be sublimation, right? But if we were going in the backwards direction, it could be deposition. Now, identify the liquid region. We've done that. Remember, that's going to be this purple region here, because at very low temperatures, you should have a solid. Very high temperatures, you should have your gas. And so that liquid is going to be somewhere in between. And then identify the supercritical fluid region. Again, that is going to be the region where we stop seeing the distinguishing lines, the phase transitions there. And so supercritical fluid will be the green. Now estimate the temperature and pressure for the triple point. So that's going to be right here. And tracing down, we should see that that's a little bit less than -50. So we may say that it's about -55 degrees Celsius. And the pressure here looks like it's somewhere in between 100 and 1,000. Notice how this is on a logarithmic scale. So let's say that it's about 500 kilopascals. Okay, so that ends our topic on phase diagrams.